In today's lesson, we're going to talk a little bit more about the shape of data, and based off the shape of the data, what kind of things we would consider when we're discussing or describing it, or even comparing it. Let's get started. When we're talking about the shape of data, we're talking about it being skewed or symmetrical. If you look at our first image here, something that is skewed left, we can see we have a cat, and the tail of the cat is on the left. So if the tail of the cat is on the left, that means most of the cat is over on the right side. So something that is left skewed means that we have a small portion of it on the left side, but the bulk of it is on the right side. And if we were to look at this maybe like as a histogram, we would see that we have some columns over here on the left, but then we have larger columns over on the right. And if we were to look at this as a curve, we would see that it would be curved, where we'd have a smaller curve on the left, a bigger curve on the right. Looking over on the other side, for our other cat, where it's right skewed, again we see the tail is on the right side, which means most of the cat is on the left side. So again, if we turn this into a histogram or a curve, we would see something more like that, where a bulk of the curve is going to be on the left side, the smaller portion is on the right side. So the tail of the cat indicates what kind of skewness we have, and the tail tells us there's a small amount of data on that side. So just to reiterate, something that is left skewed has a small amount on the left, which means that most of the data is actually going to be on the right side. If something is skewed right, that means most of the data is actually going to be on the left side. All right, let's talk about something that's symmetrical. If something is symmetrical, that means that it's basically even right down the middle. So I could take my graph here, I could draw a line down the middle of it, and it is pretty much the exact same. So the data is basically in the middle. Which means you have a small amount on the left and a small amount on the right, but it's the same amount on both sides. And now let's talk about the best center. If you have something that is skewed, doesn't matter if it's left skewed or if it's right skewed, the best center is always going to be the median. So if it's left skewed or if it's right skewed, the best center to describe the data is going to be the median, because that is always going to be the middle of the data. If we have something that's symmetrical, we would say the best center would be the mean. Now the reason why we wouldn't use the mean for something that is skewed is the mean is an average of numbers, which means that if I have something that is left skewed, I have some small amount over here on the left, that's going to take my mean and make it smaller because we're averaging in smaller numbers. Over on the right side, if I have a bigger value because it's right skewed, that's going to make my mean bigger. So the mean is almost always affected by things that are too big or too small, or by the tails of the graph. When something's symmetrical, we have the exact same amount on both sides, so the mean's going to be unchanged or not as affected as much by things on the outside, which is why it's a better indicator, again, when we have a symmetrical graph. All right, so for our two Box and Whisker plots here, we're going to do two things. We're going to describe the shape, which means is it skewed or symmetrical, and then we're also going to decide what would be the best measure of center, median or mean, based off of the type of data we have, or the skewness. Let's take a look at our first Box and Whisker plot here. We can see that there is a portion on the left and the right, and this right portion is definitely a bit longer, and we've kind of talked about how that indicates where our tail would be. So that longer stretch is going to tell us that this Box and Whisker plot is really skewed to the right. Let's compare that to our other Box and Whisker plot. If you look on the outsides, it looks pretty equal, and even on the inside, looks pretty equal. So for this one, because we have the same amount on either side of our median, I would say this one is definitely going to be symmetric. Okay, now let's talk about the best measure of center. Anytime something is skewed, automatically we're going to be using the median as our measure of center, because the median is not affected by those numbers that are too big or too small. It's not pulled by the tail. If something is symmetric, then we would go ahead and say the mean is going to be the best measure, because it's equally affected by both sides. The amount of information on the left and the right is the exact same, so the mean is going to be a good estimate or the best average of the data. All right, so now we have some histograms instead of some box plots. I want you guys to go ahead and look at this and see if you can determine what you think the shape is against it's skewed one way or the other, and then based off of that, what will be the best measure of center. So go ahead and hit pause now, and then come back and check and see what your answers were. Alright, so if we look at our first histogram, we do have a small amount of data over here on the right side, and those small columns are going to indicate to me that that is where my tail is. So I have a skewed right histogram, and because it is skewed, doesn't matter what side it's skewed to, we'd say the median is the best measure of center. Looking at our other one, it's not perfect, but we do have, a couple things on the left over here, a couple columns on the right, and it looks to be about the same. It's not perfect, but this one's definitely going to be better described as being symmetrical as opposed to being skewed, because it's roughly about the same on both sides. If I were to take a line and draw it down through the middle, you can see that on both sides of that line, we have, again, roughly half the data that is evenly distributed, again, supporting that it's symmetrical. And again, because it is symmetrical, we would say the mean is the best measure of center because it averages all the values that are evenly distributed, and it best represents the middle of the mean. So hopefully this explains shape and also the measure of center. Go ahead and start working on the homework, and good luck.